My name is Dan Sitso, and I'm a professor and the department head of Earth, Atmospheric, and Planetary Sciences at Purdue University. The stratosphere is the second highest layer of our planet's atmosphere. It's above the troposphere, which is the layer that humans live in. It's important for us because it contains the ozone layer, which protects us from ultraviolet radiation. It's a very stable part of the atmosphere, but because it's so high up, it's much less studied than the troposphere. The stratosphere is important to study because it has the ozone layer in it, which protects humans from ultraviolet radiation. So as our climate changes, we're very interested in changes that could propagate into the stratosphere, change that ozone layer, and have impacts on humans and other life forms on the surface of the planet. Stratospheric research is not easy because it's such a high layer of the atmosphere, so we have to use almost unique airplanes that belong to NASA. So examples of those are NASA's WB-57 and NASA's ER-2 aircraft, which allow us to bring a substantial number of payload instruments into the stratosphere. One of the advantages of using NASA research aircraft is that we can sample the stratosphere in a variety of locations, really anywhere that the planes can access. And so that was one of the things that we did on this project, was to use two different aircraft in multiple locations. These included over the central US, over Alaska, as well as over the Southwest Pacific. One of the interesting results from the studies that we did this year was understanding not only is there meteoritic material that we find in the stratosphere, that is the remnants of meteorites as they enter the atmosphere and ablate in the Earth's atmosphere, but we started to see products that are from the burn up of launch vehicles and satellites entering the atmosphere. And so this was a new result, the mixing of these two types of components, meteoritic material, which is natural, and launch vehicle and satellite remnants, which are man-made. We've known for a number of decades since we started launching rockets into space that some of that material would burn up in the atmosphere as it re-entered. But we hadn't really seen that signal yet. It was dwarfed by the natural meteor flux that came into the atmosphere. In recent years, that material from human launches is outstripping or rivaling the amount of meteoritic material coming into the atmosphere, and so we're just starting to see that signal. Our stratosphere is changing because of climate change, so as the lower atmosphere warms, this propagates into the stratosphere. So we know that there are reasons that the stratosphere will change because of climate change. This is new because now we see that there are changes to the stratosphere from above as we see these launch vehicles re-entering and burning up in the atmosphere, and that material falling down through the stratosphere. So that is the new result from this study. Meteors have come through the stratosphere really probably since the beginning of the atmosphere on Earth, so this is not new at all. There's always been a natural influx of material from meteors as they enter the atmosphere. What's new about this is the material that's coming in from spacecraft, from launch vehicles as they re-enter the atmosphere and mix with that natural material. So now we're seeing that these small metallic particles in the stratosphere are not purely from natural sources, they have a human component as well. This is a global issue in that this material enters the upper atmosphere, and as it filters down through the layers of the atmosphere and ultimately into the stratosphere, it mixes across the surface of the planet. So there is no local event. This is something that happens from the North to the South Pole and across all longitudes. We don't entirely understand the importance of this finding yet, other than to understand that we are changing the particulate matter in our stratosphere. And that means that the chemistry of the stratosphere is going to change. That means that things like our ozone layer could be perturbed by these changes, as well as clouds that form in our stratosphere could also be changed by this material.